Section 3.3, solving multi-step equations. So tonight we're going to look at a bunch of multi-step equations, and what you'll notice here is your work is going to have sometimes 2 steps, 3 steps, maybe even 4 to 5 lines of work depending on the equation. So you'll want to pay attention to things like making sure that those equal signs are lined up, and also paying attention to what you're supposed to do first. And we'll go through many different scenarios, and then at the very end I'll kind of show you a roadmap of what proper steps you want to take given certain circumstances, like a basic 2-step equation, or maybe a distributive property situation, or combining like terms, or even dealing with some reciprocals outside of parentheses. So you want to pay attention to all of those things. And we'll kind of build up from the easy to the more complex. Okay, so let's start with something a little basic. It says, when solving a linear equation, first undo the addition and subtraction, then undo multiplication and division. And I want you to have pencil and paper. I do want you to copy down these practice ones as we go along. See if you can do them on your own or do them along with me. It's going to help you when it comes time to do the blue examples. So don't wait until the blue examples tonight. I want to see these on your paper as well. Here we have what we would call a basic 2-step equation. And when I see a basic 2-step equation, the story that kind of goes along my head is one that relates to middle school and high school. I kind of see this scenario where you have a girlfriend and a boyfriend, and they're dating, and they're kind of, they're really close, almost like disgustingly close. You can't really separate them. And then there's always like this third guy who really wants to date the girl, and he's trying to get in there, but he's sort of like, blocked out or whatever. He's kind of like just a third wheel. And then you come along and you're interested in this girl as well, but she's already got a boyfriend, some other dude interested in her. You're kind of like, in fourth place, so to speak. So in this scenario, I would say that, the girl is kind of like X. All right, and she's involved in this relationship already with the 4, okay? And we're going to call them the couple. So you're going to have to deal with that couple. But then there's also this negative 4 out here. Notice the negative 4 is a constant. He's kind of all by himself, this guy right here. And so that guy we're going to call the loner. He's the third wheel. Okay, now who do you think it would be easier to kind of get out of the way first? In other words, who has the weaker bond to the X right now? And if you think about that, that's going to be the loner. So what I'll always say when we have a 2-step equation is you want to take out that loner first. You always want to take out the loner first. Then you can come around and destroy the couple when you're ready. Okay, so let's take out that loner. How do we get rid of a negative 4? Well, you're going to add 4 to both sides. Notice I say both sides, not all numbers, right? I'm not going to put a plus 4 under this because that's also part of the left-hand side. I've already added 4 to the left of the equal sign. I just have to add a 4 to the right of the equal sign as well. All right, when we add the 4, those guys are going to cancel out, and we're going to be left with 4x on the left. We have a war problem. Negative 12 plus 4 is going to be negative 8. And that would be step 1 of your 2-step equation. Notice now the couple is isolated and we can destroy the couple. How are the 4 and the X glued together, right? They have a stronger bond. Well, they're glued by multiplication. What are we going to do to unglue them? Well, we're going to use division, right? We're going to do an inverse operation. So to get rid of that 4 now, we're going to divide by 4 on both the left side and the right side. Okay, and you're dividing by 4 on the whole entire side. All right? When that happens, the 4 divided by 4 is going to make a 1, so that cancels out, and you're left with x on the left. Negative 8 divided by 4 is negative 2, so x equals negative 2. You do want to take that negative 2 and plug it back in the original location of x just to make sure it makes sense. 4 times negative 2 is negative 8. Negative 8 minus 4 would give me a negative 12, so this guy definitely checks out. And that's your basic 2-step equation. You want to take out the loner first and then destroy the couple. All right, very good. Let's move on to something a little bit more complex, because they won't always be basic 2-step equations. It says sometimes it is necessary to simplify by combining like terms first. Take a look at this one. Okay, we have a little bit more stuff on the left this time. And so we don't really want to talk about couples and loners yet, because if you look up here, you kind of see a couple here and a couple here and a loner here. We don't really, that's too many couples as far as I'm concerned. Let's go ahead and link up those x's together. We'll combine the like terms, and then it's going to take us to a simple two-step equation. So what I'm talking about is, let's go ahead and combine what we can combine. Notice when we talk about combining like terms, we can only combine like terms on one side of the equation. All right? The 17 and the -4 might look like terms, but they are also on different sides of that equal sign. They're across the boundary. So you cannot combine those. You can only combine things that are on the exact same side. So the 2x and -9x are on the exact same side. We can combine those. 2x minus 9x is going to be -7x plus 17 equals -4. That would be your first step, combining like terms. And then you see we have a basic two-step equation here. What are we going to get rid of first? Are we going to get rid of that -7, or are we going to get rid of that 17? Okay, well, we will take out the loner. That is typically what we're going to do first. So let's take out that 17. -17 on both sides. 17 and -17 cancel out to make a 0. And we are left with -7x on the left and -21 on the right. Notice we're kind of dealing with good numbers here. The numbers won't always be good. You'll have fractional and decimal answers. But for right now, for our practice problems, typically we'll use some easier numbers. Okay, we've got that couple left. The -7 is glued to the x by multiplication. We're going to get rid of it through division. Divide both sides by -7. And that will leave us with x equals +3. Okay, notice we have 1, 2, 3, 4 lines of work, pretty much, 3 or 4 lines of work. Equal signs are lined up, and notice that there's sort of this taper that happens. Okay, by the time you get done with your answer at the bottom, you might not see an exact V shape, but you'll see a lot smaller real estate up there. Let's plug in the 3 and just make sure that we get the right answer. 2 times 3 is 6. 9 times 3 is 27, so we might have something like 6 minus 27 plus 17 equals -4. I got to go left to right on this, so I'm going to do 6 minus 27. 6 minus 27 is -21 plus 17 equals -4. And that works out. -21 plus 17 is -4, and -4 equals -4. So that's just what's going on in my head as I'm double checking to make sure that I do have the correct value for x. And you always want to do that yourselves. Okay, so sometimes we'll have to do combining like terms first. Here's another thing we might have to do before we deal with loners and couples. Distributive property. Sometimes it is necessary to simplify by using the distributive property first. Let's take a look at that. 4x plus 12 times the quantity x minus 3 equals 28. Okay, this is another multi-step equation. And here, if you have something that can be distributed, you want to distribute first. Okay, so we're talking about this region right in here. We want to distribute that 12 to both the x and the -3. Is the 4x over here going to distribute? No, it's removed from that whole situation by the plus sign. So the 4x can just drop down. But what I'm really doing first is distributing that 12. So 12 times x is going to be positive 12x. And positive 12 times -3 is going to be -36. All equal to 28. So notice I use the distributive property first. Now what do you think I can do? Well, I can combine like terms. Okay, I have a 4x and a 12x on the same side. That's going to make 16x. Remember, you can only combine like terms on the same side. 16x minus 36 equals 28. And now I have a basic two-step equation. Okay, I'm going to take out the loner first. Which of these numbers is the loner? Well, that is the -36. I'm going to add 36 to both sides, thus canceling that out, and I'm left with 16x on the left and 64 on the right. Okay, to get rid of the couple now, that's the 16 and the x glued together, I'm going to divide both sides by 16. And hopefully final answer, x equals 4. You want to take that 4 and maybe plug it back in up at the top. When you do that, it will work out. 4 is the correct answer. So notice we have 4 or 5 lines of work there. Make sure it's all nice, neat, and organized. You'll want to do distributive property first, and then often you'll have some like terms to combine when you're done. Let's do another distributive property example. Sometimes when you're doing that distributive property, you'll have to deal with a negative sign that also gets distributed. So here it's not just a 5 that's being distributed, it's a -5. So just make sure that you pay attention to your signs as you're multiplying. This 2x isn't really part of the action, but we are going to distribute -5 times x, which is -5x. -5 times -9 is +45. And that's all set equal to 27. Okay, what do you think your next step would be? Well, we do have like terms. On the left-hand side, we have 2x minus 5x. That's -3x. So -3x plus 45 equals 27. And now we have a basic two-step equation. All right, I'm going to get rid of that loner first. So I'm going to subtract 45 from both sides. Okay, and when I do that, I get -3x on the left is equal to, and here I have a type 1 subtraction that basically turns into a war problem. Negatives win, and they win by 18. So I'm left with -3x equals -18. And to get rid of that couple, to destroy that couple, I will divide both sides by -3. And I end up with x equals 6. Remember, to make sure that we're dealing with the right answer, you do want to go back up in there and plug in that 6. And you'll have to plug it into 2 separate places. And you can kind of do it mentally right now. I'll do it right now with you. I start inside the parentheses, and I get 6 minus 9 is -3. And that -5 times -3 is a +15. And then the 2 times x, 2 times 6 is 12. So I end up getting 12 plus 15, and guess what that equals? 27. So that is equivalent on both sides, which means 6 is the right answer. So you always want to double check. Okay, so far so good. We have one more scenario that is the one that always gave me a hard time. It's probably because I didn't listen to my math teacher. So I'm going to try to help you out here and prevent you from a little heartache and going down the wrong road. Okay? If you take a look at this problem, it looks like another distributive property problem, and it is. Okay, it says 12 equals 3/10 times the quantity x plus 2. And that 3/10 is kind of like a coefficient on the outside, and it's multiplying both things in the parentheses. So your gut instinct is probably going to be to try to distribute this 3/10 to the x and to distribute this 3/10 to the 2. And if you did that, you would get 3/10 x plus 6/10. And there's nothing wrong with that, but fraction operations can get pretty dirty and nasty, and if you can avoid them easily, it's usually just better to avoid them easily. Don't get me wrong, you have to be able to work with fractions, but if they can be avoided, it just might save you a lot of heartache, might save you a lot of time. So here's what we're going to do. Read what it says up top. It says sometimes it is easier to multiply by the reciprocal first rather than to distribute a fraction. So instead of trying to distribute this 3/10, since it's on the outside of those parentheses and it's multiplying the whole inside, let's get rid of it by just multiplying it by its reciprocal. In other words, we're going to multiply both sides by, what's the reciprocal of 3/10? 10/3. And I can do this because you can do anything you want in an equation, just whatever you do to one side, you have to do to the other. So I'm going to multiply that 3/10 times 10/3, but I'm also going to multiply this 12 times 10/3 as well. And remember that 12 is on top. It's like 12 over 1. So if you want to write it like that, it's fine. So I'm multiplying both sides by 10/3. thus keeping everything nice and balanced. Let's watch what happens. Okay, let's handle this right side first. Watch this. 10 on top and 10 on bottom cancel. 3 on bottom, 3 on top cancel. So that just makes a big fat 1. So it's 1 times x plus 2, which is basically x plus 2. And the nice thing is, since we only have x plus 2 left over here, you don't really need to have those parentheses anymore. They can go away because you don't have to protect them from anything else. Let's see what we get on the left-hand side. 10 times 12 would be 120. It's going to be 120 over 3 times 1, which is 3. Okay, so that's 120 over 3. We know that that's going to be 40. You could also cross-cancel here. 3 divided by 3 is 1. 12 divided by 3 is 4. So 10 times 4 is 40 over 1, or just 40. Okay, and that is a much nicer looking equation. 40 equals x plus 2. I mean, that's not even a two-step equation. That's a basic one-step equation. We just need to get the x by itself. All you would need to do at this point is what? Well, take away the 2. And you get 38 equals x. So save yourself some struggle and some time. If you have a fractional coefficient like that, go ahead and multiply it by its reciprocal. It's just going to make everything a lot easier. If you plug back in this 38 for x, it will work out. All right, very good. Last thing before you do these on your own, I went ahead and created this slide for you. It's a very important slide because if you get stuck, you want to come back here and maybe see where you might have gone wrong. These are all the steps that we just went through. And notice down at the very bottom, steps 4 and 5. This is our basic two-step equation. You want to take out the loner first and destroy the couple. And if you have a two-step equation, you just go straight to steps 4 and 5. But numbers 1, 2, and 3, these guys up in here, this is what you might need to work on before you're left with a basic two-step equation. And this is the order that you would handle things in. So if you have that reciprocal situation that we were just in, you're probably going to do that first. If it's a fraction that wants to distribute, multiply it by its reciprocal. All right, if it's a whole number that wants to distribute, go ahead and use the distributive property. Okay, and then if you have any like terms, you'll deal with that. So if you just kind of follow that order, of course, you're not always going to do all 5 of these steps. That's why it says if necessary out here. It's going to depend on what you're looking at. Okay, but this would be the preferred order that you go in. All right, pencil, paper ready. You should already have them out because you've already been doing some work on it along with me. Now you're going to try these on your own. Okay, so we have many examples tonight. Here are numbers 1, 2, and 3. I do want you to do these on your own. Circle your answer. Check your answer before you come back with me to go over answers. But you should already be able to prove to yourself that you get these right. And make sure you follow each step, having that taper in your work, all equal signs lined up. Go ahead and do number 1, 2, and 3 on your own. You can hit pause now, and then we'll reconvene to go over answers. Okay, let's see how we did. Number 1, basic two-step equation. So we begin by taking out the loner. We're going to add 43 to both sides. And that leaves us with 5x equals, that's a war problem, positives win. They win by 30. So we get 5x equals 30, divide by 5, divide by 5, x equals 6. So hopefully you got x equals 6 on your first problem. All right, number 2, we have a fraction to deal with here. X over 6 minus 7 equals negative 5. So that x and 6 are glued by division. Remember, we're going to multiply both sides by 6. Or 6 over 1, however you want to do it. Okay, multiply both sides by 6 to get x by its... Oh, what did I do wrong? Well, that's totally not the right thing to do. See, I went for the couple first, okay? And you can't actually do that. You have to take out the loner first. And that's a common mistake, all right? I almost made it myself right there. But in a two-step equation, you have to take out this guy first. Otherwise, you're not going to end up with the right answer. Okay, so let's go in order. We're going to add 7 to both sides. Okay, when you add 7 to both sides, you're left with x over 6 equals positive 2. See, it would have been very easy for me to get the wrong answer there. All right, now we're allowed to deal with that x divided by 6. This is destroying the couple. We're going to multiply by 6 on both sides, thus canceling out the 6 on top, 6 on bottom, and I'm left with x equals 12. That's the number that's going to work when you plug it back in. If you come up here to the top, you plug in a 12 here. 12 divided by 6 is 2. 2 minus 7 is negative 5. So this guy is the right answer. All right, let's take a look at number 3. Now number 3 is a little bit more complex, but we have like terms to combine first. So notice that this negative 8x and the negative 3x, those are like terms. So I can go ahead and combine those. And when I combine those make negative 11x. Okay, it's a get mugged twice. You lose 8 plus you lose 3, you've lost 11. So negative 11x plus 15 equals the negative 29. And now I have a two-step equation. Take out the loaner first. I'm going to subtract 15 from both sides. When I do that, I'm left with negative 11x equals negative 44. Divide by negative 11, divide by negative 11, and we get x equals positive 4. And hopefully all of your work matched up with that. Okay, let's move on to some more examples. Go ahead and try these on your own. Notice that you have some quantities in the middle there, so you might be using some distributive property. And if you're not sure which steps to do, what things to do first, go back and look at that steps page I created for you. It'll help you out. All right, go ahead and try these on your own first, then we'll reconvene to go over answers. Okay, let's see how we did. On number 4, we're going to have to distribute that 3 first. Remember, the 5x is not really part of the action. We're just going to drop him down. Positive 3 times positive x is positive 3x. Positive 3 times negative 7 is negative 21. All of that is equal to 59. So we distributed first. Now we're going to combine these like terms. Positive 5x and positive 3x make positive 8x. So 8x minus 21 equals 59. And then let's take out that loaner. We're going to add 21 to both sides. And that leaves us with 8x equaling 80. Nice numbers. Don't always expect nice numbers, but these are nice numbers. And divide by 8 on both sides. Creates a 1x, or just an x. So x equals 10. You want to go back and plug in that 10, but it's going to work out. It's going to look good. Okay? And so you can see I have 4 lines of work there. You also need to have 4 lines of work on your paper. Let's go over to number 5. This one's even more complex. We want to distribute that negative 3 first. 7 and 5x are not part of the action, so we can drop them both down. 7 plus 5x. Okay, but now we're going to distribute that negative 3. So negative 3 times positive x is going to be negative 3x. Negative 3 times negative 2 is going to be positive 6. Make sure you get your signs right there. All equal to 27. Now notice we have a lot more like terms this time. Not only do the 5x and the negative 3x, not only do those make 2x, we can combine those, but we can also combine the positive 7 and the positive 6. And that's going to make positive 13. So a double combination there. 2x plus 13 equals 27. And then I'm going to take away the loaner. So get rid of the loaner. Taking away 13 from both sides. And that leaves me with 2x on the left and 14 on the right. Divide by 2, destroying that couple, and I get x equals 7. All right, hopefully you did well on those. Got a couple more for you. Go ahead and try this one. Notice that fraction that wants to multiply that quantity. Let's see if you remember how to handle that. Go ahead and try this on your own first, and then we'll get together to go over your answer. All right, let's see how you did. You know, your gut instinct might be to distribute that 5/8 to both the x and negative 3. And if you did that, you'd get 5/8 x minus 15 over 8. You're going to get some nasty fractions there. They're not going to be fun to deal with. Let's go ahead and just get rid of that 5/8 now. So we can multiply it by what? Its reciprocal. So multiply this whole side by, by 8/5. And whatever you do to the left, you also need to do to the right. So I'm going to multiply this side by 8/5. And that 15 is like it's over 1. Okay? 8/5 and 5/8. Remember, those are the multiplicative inverse of each other. They basically make a 1. 40 over 40, it's going to be 1. 8 and 8 cancel, 5 and 5 cancel. And you're left with 1, or just x minus 3. And remember, like I said, we don't even need those parentheses. Okay? 15 times 8 is 120. 1 times 5 is 5. I could have cross-canceled, but that's okay. And then let's go ahead and simplify this. X minus 3, don't need those parentheses really. And 120 divided by 5, I believe, is 24. That's a pretty easy one-step equation now. We got to get x by itself, so let's add 3 to both sides. And you get x equals 27. And you probably should plug in that 27 and make some sense out of it. So when we plug in 27 up here to test it out, 27 minus 3 is 24. And so what we're really saying is 5/8 times 24. You don't actually have to do that, but think about it. 5/8, it's a little bit more than a half, right? It's a little bit more than 4/8. Half of 24 is 12. Well, 15 is a little bit more than that. So I am expecting a number that's a little bit more than half of 24, and 15 fits the profile. So I'm feeling pretty good about that, just with sort of the estimation in my head. Of course, if you want to multiply it by the 5/8, knock yourself out. All right, last one. See if you can do this one here. Negative 4 equals negative 1/8 times the quantity x plus 3. And if you didn't get that last one, this is a chance for you to redeem yourself. So go ahead and try it on your own now. You can go ahead and hit pause, and then we'll reconvene to go over answers. All right, let's check it out and see what we come up with here. So that negative 1/8, we're not going to distribute it. We're going to multiply it by its reciprocal, which is negative 8 over 1. You can see I kind of left you room to be able to do that. That's why the problem looks a little bit awkward. Now we're going to multiply this negative 4 also by negative 8 over 1. Okay, and let's see what ends up happening here. 8 divided by 8 is 1, 1 over 1 is 1, and a negative times a negative is a positive. So all those things cancel out, and we're left with x plus 3 on the right. And remember, those parentheses, we don't even really need them. All right, on the left-hand side, negative 8 times negative 4 is positive 32. So we get a positive 32 over 1. We'll just write down 32. So 32 equals x plus 3. We've got to take that 3 away to get x by itself. And when we do that, we end up with 29 equals x. All right, I know that was a lot of examples tonight, but you have your first quiz coming up here soon. It's not going to be easy, and you need as much practice as you can get. And I tried to go over as many of the different scenarios that you might encounter. So I hope you listen carefully. If you have any questions, obviously ask them tomorrow in class. Good job with this, and good luck on the assignment.